So, questions? Thoughts? Ideas? How did you like the test? Oh, I see. Well,
yeah, I'm wondering that it should have been right, but it didn't like how it
I actually was looking at it. I guess this morning I was looking at it. Out of 52 students, I guess 52 students signed up for it. 47 actually completed it. There's 5 of you that actually did not finish it. I guess the point is, when you go to the end, it basically tells you when you're done with the test, and so it just said it's incomplete. But anyway, that's I guess something else that we can talk about. But let's see. I did not get a chance to actually go through every single one of them because it takes a very long amount of time to actually go through every single problem that people got wrong and everything else. The average, I think, at this point is like 45%. There's people that actually scored in the 80s and in the 70s. And of course, there's people that scored in the 9%. The one thing I should say, and I kind of told you this before, ahead of time. The point is, this is kind of an assessment to kind of gauge where you are at this point. Did I forget to set up the microphone?
You might have joined the wrong class. You're in 313. So that happened to Shannon once. So you'll have to just do a file quick, like exit, and you'll just switch. Which is when you log in.
That's fun.
Yeah, so you can do a sign out down here, like switch courses. Yeah. So.
Sorry, apparently I clicked on the wrong class.
Yeah, there you go.
Why are they different, by the way?
They just change. And
where do I have to go now?
Chat.
Okay.
They just change it a little bit every semester.
No, because the two classes are different, one from the other.
I don't know. They're in the shells, so it's just a black bar. And then
lead session.
Yeah.
Sorry about that.
No problem.
Okay, so basically, as I said, this is more or less of a test. As I said, next semester it's going to actually be set up as a placement test, and so for now, it's kind of, if you scored, well on it, or if you didn't score well on it, it's, I can't actually just, if I deem that you're not necessarily well prepared for the class, I can't actually kick you out because it's not actually a placement test. It's just basically a guideline that should tell you where you're more or less at. So based on what I was kind of looking at things, I would say that if you scored anywhere in the 10s or the below 20% or so, you probably need to figure something out, in the sense that 20% means you basically got 6 problems correct out of 34, which there's a few problems that are actually not very hard, and actually there's some of them that are multiple choice, so I guess you could potentially get lucky on a couple of them. But anyway, so what I'm going to do for the next couple of days or so, my goal is to get it by Friday, but I might not necessarily be able to, is I actually have to go through every single person's test and see why you got the problems wrong. But I do have a few ideas. I've seen that people mightily struggled with absolute value problems. Those seem to be really, really fun. So anyway, do you have any questions? Yes.
Could we do number 25? I couldn't figure that one out.
Yes.
Okay. What is your question?
I thought that the test was due today on Wednesday.
Uh-huh.
And that's why I didn't turn mine.
Oh, I see.
Yeah.
Yeah, there's, as I said, there's 5 of you that actually show that the test is incomplete. If you don't know exactly who that is, I can actually tell you. And so I would like you to actually log on, maybe after the class, and just basically make sure you actually submit the test. That way it actually is recorded officially. So anyway, but that's, and you can ask me if you have issues. Yes?
If this was a placement test, what percentage would we have needed to get in order to stay in this class?
I don't know.
I think most of us remember learning this stuff, but it just doesn't come back to us.
I don't know, and that's the honest truth. I have a feeling that that's why we're, as I said, that's why you're actually the guinea pigs. We're trying to assess more or less where students are and everything else. So I would say clearly if you would score below 30%, then you probably shouldn't be in this class. And that's just because of the way the things work. You have a question?
Some of the stuff I saw on the test, I didn't learn in pre-calc, and I got a business teacher last time to teach me this. So.
Like what stuff?
The difference of quotients.
Yeah.
That was a big one.
I got one
Okay.
every time.
Okay.
Yeah, I got one.
I've seen some answers in which the answer was 1, which means I would like to be curious to find out how you actually got 1, because in general the only way you get 1 on that is if you actually have a very deep misunderstanding of functions, in the sense that, and I'll say a couple of words about this. So I can probably say that now with relatively ease. The point is, f of x plus h does not equal f of x plus h. So my guess is if you got 1 for every single one of them, this is probably something that you did. And
Exactly what I did. I just plugged everything in, and then it all ended up canceling out algebra. So.
okay. Well, we can look over some of the things and see exactly how they actually apply. So anyway, let's see. You said you don't know how to do number 25, right? Okay. Well, before we get there, what I was planning on doing today was basically pull out the actual test, and I can basically go through the test that I took, and you can basically see what the difference, or we can see where you're more or less struggling with things, unless you actually have more specific questions. One of the things that I've noticed based on looking at, and I didn't actually look at all 50 tests, but looking at I probably looked at more than 10, 15, kind of like that, and I just kind of glanced through them without actually spending the time to realize or see exactly what the differences were. I've noticed that a large class of people are struggling with absolute values. Basically, what that basically says is, I looked at tests. Obviously, if I look at the test that scored 85%, chances are that person didn't really struggle with the absolute value problems. But if I looked at tests that were like in the 30s, in the 40s, in the 50s, and it seemed like pretty much every single one I looked at, there were issues about the absolute values. And so that's where I would like to start first. But should I pull out the test?
Yeah.
Okay. Okay, so I guess you can probably see the list of all the students that took the exam. This is actually the 54. So I guess 2 more people attempted the test in the last hour and a half. So anyway, I just load up the test. As I said, one of the things that when we started this, I actually took the test first, just so I get a feel for what things are. You'll notice that I got 5 problems wrong. The last 3 problems I didn't even attempt, so that's basically where 3 of them come out. As I said, I don't necessarily care about them that much because they don't really play a role in calculus that much, and so I don't necessarily, besides, I took the test in 30 minutes and I had no calculator with me, so I just figured, well, whatever, I'm not going to worry about it. So, okay. Any questions about this? So basically the first question, or the first line of questions would be inequalities. And remember, on Monday, I basically cheated and I pretty much told you more or less how to do these. Do you remember how to do these? Now, as I said, the first problem actually is very simple in the sense that it's a quadratic. The leading term is positive, which means your solution set is going to be outside of the roots. Remember we talked about this last time? And so as a consequence, you basically have to look outside of the roots. And the roots are going to be -8 and 4. Is that making sense? Okay. Let's see. Second problem. It actually is a little more complicated in the sense that you actually have to factor it first. But that's basically the only thing, right? You need 2 numbers, their product is 15, their sum is 8. 3 and 5 do the trick, right? So -3 and -5 are your 2 roots. Again, the constant in front of x squared is positive, which makes it go outside of the roots, and so you end up with this answer. Is that making sense? Okay. Stop me at any given point if you have a question. Number 3, it's a little more complicated again in the sense that you actually are looking at 3 roots. So, do you have any questions about this? As it turns out, and again, I've kind of cheated about doing these. I just wanted to see what the problems were. I personally, what I basically assumed is it's a cubic function. Cubic functions, especially if the leading term is positive, are increasing. They start at -infinity, they go to +infinity. So I'm basically going to look at a function of this nature. Since I have 3 roots, it means that I have to have 3 points in which it crosses it, right? I'm looking for when the function is negative, which would mean I'm looking at the first part and then the third interval. So that's why this is what I'm going to come up with. Otherwise, if you actually want to do it by paper, should I go in more detail with this? You basically look at the 4 intervals. This is what I was saying last time. Maybe I should just say a couple of words about it. Okay. We're looking at 7, -7, and 4. So I'm looking at -7. That's a 7. Let's try this again. -7, 7, and 4. And so I'm looking at -infinity to -7. -7 to 4. 4 to 7, and 7 to +infinity, right? And so all you have to do is just basically test them out. If you don't get any other creative ideas flowing, then you just basically test each interval, put in a point, see if it's negative or positive, and that's basically how you solve things. Is that making sense? Okay. So moving on. The next one was a fraction, And the only difference versus the previous problem was the fact that you have to take into account that the denominator can't be 0. Okay? And so that's one of the things that you have to look for. And again, you can think about this as being a cubic function. You have three terms, so you're going to have the same kind of idea. And so this is what we're looking at. The only difference is that 1, and I've seen this on some papers, the reason why this is not right is because 1 cannot be part of the solution, since you can't divide by 0. And I've seen this on some tests, as far as being the wrong answer, which it is a wrong answer, but it's not necessarily that dramatic in the sense that at least you knew which direction you're going into, and that's just a little bit of a issue. Questions? Move on. Okay. Solving a cubic. Do you remember how to solve cubic functions? You have to factor it, right? The whole point is you are trying to factor it. How do we factor it? Because we don't have a quadratic formula, or we don't have a cubic formula, I should say, right?
Can you take an x out?
You cannot take an x out because 12 doesn't have an x next to it.
You move it over and then take an x out.
No.
That's what that is. Yeah.
Yeah, that's what I did.
Yes, one way of solving this is actually try and factor it by grouping, which would mean you can factor out the first two terms and factor out the second two terms. Last two terms. So notice that you can factor out an x squared from the first two, and you end up with x squared times x minus 3. You can factor out the negative 4 from the second one, you end up again with x minus 3, which means it ends up being x squared minus 4 multiplied by x minus 3. And then you can factor out some more, and you come up with this idea. Yes?
Show that?
Yes, I will show it, and let's see how creative I can be with this tablet. If you're wondering what in the world I'm saying, I usually write it as a tablet, so I turn it around, but then I don't have a keyboard, so I can't actually show you the tests later on. So, okay. A few things. Let's start off with basic algebraic operations. Okay. If a times b is equal to 0, that's then. Okay, enough of this. I'll try and maneuver around it in such a way that we can actually use it later on. So, hopefully, no lights will be flickering. Alright, that wasn't that bad. Okay, so if a times b is equal to 0, then a is equal to 0 or b is equal to 0. Okay, this is the zero multiplicity idea, and so the point behind this is the fact that we want to factor things out in such a way that we actually can go with one factor or the other. And so basically the point is, if I have x minus 2 times x minus 3 is equal to 0, this means that x minus 2 is equal to 0 or x minus 3 is equal to 0. Okay? The reason why I'm going through this is because I've heard some of you say, I moved the 12 over there and then I factored out an x. And what I'm trying to get at is the fact that if I would start off by saying x squared, what is that, minus 5x plus 6 is equal to 0. Okay, let's break this. I don't like this. So, let me try this again. X squared minus x minus 6 is equal to 0. Let's try it that way. You cannot say that x squared minus x is equal to 6. X times x minus 1 is equal to 6, which means x is equal to 6 or x minus 1 is equal to 6. Is everybody understanding why this is very wrong? Yes? Or should I say a few words about it? Is this making sense why it's not true?
Why is it true?
The only reason why, the only way you can actually come to something like this is if it's actually equal to 0. Notice here that x equal to 6 forces x minus 1 to be equal to 1. Otherwise, 6 times x minus 1, or better yet, let's actually even, put it in. X equals to 6. Come back here. What are you saying? You're saying that 6 times 5 is equal to 6. Is that making sense? Similarly, x minus 1 is equal to 6. That means x is equal to 7. Come back here, you're saying that 7 times 6 is equal to 6. Is everybody understanding how this works? So the only way you can say that is, in fact, if you actually end up with zeros. And so if you're given any polynomial, any size polynomial, and you're actually asked to solve it, the first and foremost step is to move all the terms into one side and just work with all of the terms at that point. You can't just move some terms on one side just because it might, make the rest of them simpler. Is that making sense? So obviously, let me make sure that this doesn't stay there for posterity and people come back later to me and say, you taught us wrong. I saw you do this in the class. It's correct. Right. Is this making sense? Alright. Next step. What happens if you have any other polynomial of a degree higher than second? So the idea is if you have a linear function, it's easy to solve, right? I'm guessing everybody knows how to solve a linear function. If it's a quadratic function, then you have two choices. Either try and factor it, or if factoring doesn't work, use the quadratic formula and you get to an answer. What happens if it's anything higher than that? So, anybody remembers what the function was? X cubed minus 3x squared minus 4x plus 12 is equal to 0. Now, as it turns out, because this is a cubic function and it actually has 4 terms, you can factor by grouping. But it's not necessarily that it's always going to work. It ends up working for this particular problem in an easy way, but it's not always going to work. So let me just come out and say factor by grouping. What it usually means is you try and group the terms and factor whatever you can out of them. So if you look at the first two terms, I can factor out an x squared. What am I left with? X minus 3, right? If I look at the next two terms, what can I factor? Well, technically I can factor a 4, but what happens if I factor a negative 4? I get x minus 3, right? And as it turns out, I have the same term in both of them. So from here I can say this is x squared minus 4, bless you, multiplied by x minus 3 is equal to 0. Okay? Which I will come back to that in a second. This is equivalent to saying x minus 2 times x plus 2 times x minus 3 is equal to 0. Which means x minus 2 is equal to 0, or x plus 2 is equal to 0, or x minus 3 is equal to 0. Is that making sense? And solving all these three is going to give you 2, negative 2, and 3. Make sense? Okay. I used one thing. Is everybody in this class familiar with this particular thing? Do you see how do you get from here to here? There's a few formulas that actually I always put on tests just to make sure everybody remembers them. A squared minus b squared is equal to a minus b times a plus b. This is called difference of squares. Okay. What you may not necessarily remember is the difference of cubes, and this is one of those formulas that I don't actually want you to memorize, because if you remember them, that's more power to you, but I wouldn't necessarily be that distraught if you don't. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Sometimes I'm lazy, and today is one of those days. I don't want to rewrite all of that. So what happens if I look at a cubed plus b cubed? As it turns out, the only difference is I have a plus b, and then I have a minus in front of ab. What is a minus b quantity squared? A squared minus 2ab plus b squared. When in doubt, put it next to each other and use your second favorite thing. I talked about your first favorite thing last on Monday, which is the slope-intercept form of the linear function. Your second favorite thing, I pretty much know, is FOIL. Right? Everybody really likes to say FOIL. So if when in doubt, put them next to each other and multiply them out, and you come up with that. Does that make sense? On the same token, a plus b quantity squared is equal to a squared plus 2ab plus b squared. Bless you. A plus b quantity squared is by no means a squared plus b squared, which some of you might think that it's obvious, but I'm just basically coming out and saying it because I've seen it on enough papers and exams in my life as teacher to know that I should probably make sure that I bring it up. Is this making sense? Okay, now I solved that particular problem, but I actually haven't told you what's the general approach of these types of problems. So if I go back to x cubed minus 3x squared minus 4x plus 12 is equal to 0, how do you actually factor a higher degree polynomial? So as I said, if you're creative enough, you can observe that you can factor this by grouping and continue on. However, in pre-calculus, the way you're taught this is to look at the factors of 12 and the factors of 1. So we look at the leading coefficient. As it turns out, it's 1. And so all the factors are just plus and minus 1. And then we look at 12. And all the factors of 12 are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus and minus 12. Which means possible roots are going to be... Oh, I really don't want to write this again. It is all the factors of 12 divided by all the factors of, in this case, 1. If I would have had a 2 here, then I would have had factors of plus and minus 1 and plus and minus 2. And so when I would come back here, I would have to take all these numbers divided by 1 and take all these numbers divided by 2. Right? As it turns out, dividing anything by 1 doesn't change anything, right? And the plus and the minus doesn't matter because I'm actually looking at plus and minuses. Which means possible roots for this particular polynomial would be either plus or minus 1, plus or minus 2, plus or minus 3, and so on. Okay? How do we test for which ones they are?
Take the 1, -3, -4, you line them all up, right?
Yes, that's called synthetic division.
Yeah.
So one way we were taught is to use synthetic division to actually figure it out. And you accomplish two things with the synthetic division. First of all, you see if it works or not. If it doesn't work, then it doesn't work. But if it works, you also actually find out the remainder. I shouldn't say the remainder, but the quotient. And so that's basically accomplishing two things in one. So do you remember synthetic division? No? Okay, so we take the number, let's say we start with 1, we put a little bracket there, and then we list all the numbers. 1, -3, -4, and 12. Is this starting to ring any bells? If it doesn't ring any bells, by the way, it's absolutely no problem. You don't actually have to know synthetic division. All you have to do is just go back into the polynomials and just plug them in. I can just come back here and say, would 1 work? Well, 1 is very easy to figure out, right? I'm just going to have 1 minus 3, that's -2, minus 4, that's -6, plus 12, that's 6, it's clearly not 0, right? So I know for a fact 1 is not going to work. I can try -1, and as it turns out, it's not going to work, right? We already solved the problem, so we know it's plus or minus 2 and what is it, 3? Right, so those are the 3 solutions, so we know neither of the other ones are going to work, right? Because we kind of cheated already. But anyway, do I need to go over with the synthetic division? Continue on? Again, you don't actually have to remember it. And if you don't want to use synthetic division, you can actually use long division. Do you remember long division? Okay, so the first thing to do is to actually drop the 1. And then we multiply 1 times 1, and you add up there. Then we add -3 and 1, so I end up with -2. And then you have 1 times -2, which is -2. Add them up, I get -6. -6 times 1 is -6. Drop it down, I end up with 6. Which, by the way, remember what I said, it's very easy to actually put in 1 inside the polynomial and see what you end up with? Remember what I ended up with? 6. That's the remainder. That's the evaluation of it. And so that's why synthetic division kind of does two things in one. Yes?
I don't know what you just did.
Wonderful. The key idea is the following. You drop the 1. You multiply the yellow circle with the 1 on the bottom. So let's see. These two end up being there. Let's see. Teal. Then I get -2 times 1 ends up being moved to -2, and so forth. So it's probably visually a lot easier to explain this way instead of being at a computer. You drop the 1, you multiply 1 by 1, you move it here. Add them up, multiply this by that, put it here, drop them down, multiply this by -1, put it up there, by 1, sorry, and then add them up. Synthetic division is nothing else but a shortened version of a long division. It's just basically cheating. Is this making sense? Yes.
Could you also multiply like everything by -1 too? Like you have to go through that whole list, like all the positive and negative?
Yes. Unfortunately, you have to go through every single one of them because they will change. Multiplying things by negative. Keep in mind why things change. -1 squared is 1. So whenever you're dealing with even powers, the -1 is not going to show up. So the only ones that are going to change are actually the odd ones. And so you're not going to have the same coefficients with just minuses in front of them. Okay. Move on with the test? Okay. So let's see if I can do this. Okay. We come to inequalities, to absolute values. And as I said, this is where I've seen, I guess, people struggle with the most. So, let's come back. To a clean sheet. Okay. You can barely read it, okay. That's good to know. Absolute values. Can you tell me what is the definition of absolute value of x? It is x if x is bigger than or equal to 0, and it's minus x if x is less than 0. Does everybody remember this? No? Do you understand why this is the case? I usually stop here for a couple of seconds just to make sure everybody understands this. The property of absolute values is that they're always positive, right? That's the whole point. How can it be negative?
Well, if x is negative.
Exactly. If x is negative, this minus makes it positive. Okay? And that's basically the whole reason why this is how absolute values are defined. Okay? Now, in geometrical terms, absolute values are defined to be distances away from the origin or distances away from a certain point. Right? Like, for instance, one simple thing to think about is the fact that if I say the absolute value of x is equal to 6, what is x?
6 or negative 6.
6 or negative 6. Why? Well, because geometrically speaking, if this is 0, how many units away from 0 can I get? I need to go 6 units away from 0, right? But I can go to the right 6 units, or I can go to the left 6 units. Does that make sense? So I will end up with my lovely minus 6 here, and I will end up with 6 over here, right? Now, what does it say if I look at the absolute value of x minus 2 is equal to 4, let's say? 4 is fine. What do I say then? The one thing you cannot possibly say is I'm going to add 2 both sides, and I'm going to end up with the absolute value of x equals to 2. Equals to 6. Do you understand why that's the case? Let me go and describe geometrically why that's the case. What are we saying geometrically by the fact that the absolute value of x minus 2 is equal to 4?
That you're 4 points away from the origin.
4 points away from the origin?
0.
We're looking at something that's actually 4 points away. But as it turns out, I have this x minus 2 instead of x. Which means instead of looking at the origin now, I'm actually shifted by 2 units at 2. That says that if this is 2 here, what I need 4 units going this way, and I need 4 units going that way. Which means that I'm actually going to end up with negative 2 and 6. Does this make any sense? Geometrically? Again, absolute values are defined to be distances away from the origin if you have nothing else, but otherwise it's distances away from whatever point you're going to have. Okay? Is this making sense? Yes?
You're solving for absolute value of x equals 6, or x minus 2 equals 4.
The absolute value of x minus 2 is equal to 4. So now that I talked about this, and this is just a geometrical, I'm just trying to give you different perspectives of looking at things, okay? So this is basically from a geometrical perspective. Now if you go back from an algebraic perspective, we said that the absolute value of x is equal to, let's call it a. Means what? X is equal to a, or x is equal to minus a. Right? Does that make sense? Okay, now I probably should have said, so now if I come back here and I say the absolute value of y minus 2 is equal to 4. Well, if I use y on purpose now because I just wanted to use a different letter. So if y minus 2 now I'm calling it x. This means that y minus 2 is equal to 4, or y minus 2 is equal to negative 4. Does this make sense? Just think about the quantity in the brackets as being, a certain letter. X, call it an elephant, call it whatever you want. The point is that gets actually worked out. And so now I actually can perform algebraic operations and say, if I look at the first one, if I add 2 both sides, I end up with y is equal to 6. Or, if I add 2 in the other one, I end up with y is equal to -2. Which luckily enough matches my geometrical solution. So apparently I did it correctly. Is this making sense? You cannot perform any operations inside the absolute values until you actually get rid of the absolute values. That's basically the key idea. The point is, the absolute value of x is actually a function. It is not just, you can't view it as just parentheses. Okay? Now here comes the inequalities interpretation of things. So, the absolute value of x is less than 4. What does that mean, geometrically speaking? Again, think about distances away from 0. It says that my value of x cannot be more than 4 units away from 0. It doesn't say which direction. It just says it can't be more than 4 units away from 0. Which means I can go all the way up to 4 units here, but I can also go all the way up to -4 units there. My solution becomes that. Does that make sense? Algebraically speaking, what we're saying is that x has to be less than 4 and x has to be bigger than -4. Does that make sense? Which means if I'm in a situation of this nature, if I have the absolute value of x being less than some letter a, this means that -a is less than x is less than a. Means x is contained between -a and a. Make sense? So now if I have a situation in which I'm looking at the absolute value of 2x minus 3 being less than, I don't know, 6. No, 6 is not good. Let's try and make numbers that are a little easier to work with. How about 5? What do we do now?
You said you remove the inequality with the equal sign.
Sorry?
You can remove the inequality with an equal sign. Then solve it out.
Okay, but putting equal here still doesn't actually get to where I really need to go, right? The one thing that I want to stress out is that I can't do anything with this 3 until the absolute values disappear.
So if you negative 5 and 5.
So the first thing that I have to do is think about exactly my above step and say, look, I have this, whatever is here, less than a quantity. This means that -5 is less than 2x minus 3 is less than 5. Is this making sense? Now I can work out the remainder of my problem. I can add 3 both sides, so I'll end up with -2 less than 2x less than 8. So I end up with -1 less than x less than 4. And so my answer is -1 to 4, open at both ends. Is that making sense? Yes.
I separate them into 2 equations. Like, I remove the absolute value. I do 2x minus 3 is less than 5. And then I'll do 2x minus 3 is greater than -5.
Okay.
Solve it that way. Can I do that?
Yes. What you end up with, if you separate them into 2 things, what you're going to end up saying is that x is bigger than -1 and x is less than 4. Right? But what you really want is, and this is where logistics come into play, and when you did absolute values, I'm sure your instructor taught you this. If you start putting this on a number line, what you're saying is this is 0, this is -1, this is 4 somewhere. I have this interval, and I have this interval. What do they have in common? Because if you remember, back in the day, and turns into intersection, or turns into union and turns into intersection, which means both conditions have to be satisfied at the same time. That means your answer is just -1 to 4. So it's okay to separate them into two, but you have to make sure at the end that you're actually combining them again and making sure you get one answer. So far so good? Okay. By the way, is this boring or is this something that you're actually not remembering and it's good to spend time on?
It's good.
Okay. What happens if I look at the absolute value of x being bigger than of a? What am I actually saying? I'm saying that x has to be bigger than a, or x has to be less than minus a. Right? Now notice one thing here. I'm actually saying or, not and. Why? Because now I'm looking at 0, I'm looking at minus a, and I'm looking at a, and I'm saying the distance from 0 of x has to be at least a, which means I am here and I'm here. I can't use and. Why can't I use and? Well, I can't be in both places at the same time. I can't be here and there. I'm either here or I'm there. Is that making sense?
Yeah.
So now when you solve it, you have to have two inequalities, and as it turns out, at the end of the solution, you'll actually end up with two intervals. Why? Well, the picture should basically describe the fact that I have two intervals, right? I have one interval, I have another. My solution will include two intervals, regardless of the fact that instead of x, I'm going to have 5x minus 15 or whatever the situation may be. Is that making sense? Should I do an example? No? Yes? No? Or yes? Okay, so quickly. 2x minus 5 in absolute value being bigger than 3. Why don't you tell me what the answer is? Two intervals? What are the two intervals? Negative 2? You sure it's negative 2? You sure it's positive 2? 1. So it's minus infinity to 1 union 4 to plus infinity. By the way, and I've noticed this on some of your exams, I have a tendency to put plus infinity, and sometimes I put it, sometimes I don't. For all the tests that you took, well, if you put plus infinity, it actually was a wrong answer. I don't know why they set it up in that fashion, but that's what they did. Which is why, as I said, I actually have to go through every single person's test and make sure that, and I understand if they got things wrong, why did they get them wrong? Just because of typing error, or because of conceptual error, or whatever the situation may be. Yes.
We're writing down positive infinity.
Mm-hmm.
Do you want us to put the plus sign?
I don't care.
Okay, yeah.
I don't care if you put it or not. I kind of have a tendency to put it, and I think it's just because, I don't know, that's probably how I was taught 1,050 years ago. Anyway, the point is, I basically just put the plus and the minus kind of to distinguish the fact that one of them is positive, one of them is negative, but no, you don't have to do that. Okay. So let's go back to the test then and see what we're looking at. I guess we're getting close to running out of time soon. Okay. Do you understand this problem? There's any point in discussing? Yes.
You keep saying something about intersection.
Uh-huh.
What do you mean by that?
This is the symbol for union, which is a U. N is a symbol for intersection. Union means, so for instance, if I say minus infinity to 2 union 4 to plus infinity, union means either one or the other. It means I'm basically combining both intervals. So picture-wise, it means that if this is 2 and this is 4, I have this piece of an interval and I have that piece of an interval. So I take the union of both of them, so I basically join both of them together. Intersection, if I look at minus infinity to 4, intersected with 2 to plus infinity, intersection turns into and. So both conditions have to be satisfied at the same time. So if I look at my picture, if this is 2 and this is 4, I'll have this interval, and I'm going to have that interval. An intersection means what do they have in common? And this is what they have in common. And so as an answer, this is just the interval from 2 to 4. Is that making sense? Okay. So coming back to the test, this is clear? Okay. Problem 8. Your favorite. There's 4 of them, right? If I remember correctly, there's, there were 5 of them, I think. And the last one, I'm sure, was really, really a lot of fun. Yeah? Yeah? Yes, okay, so let's see. As it turns out, difference quotients will come into play in calculus quite a lot. And it'll be basically maybe the next 3 weeks or so when we'll really start seeing difference quotients for what they really are. But before we get there, the one thing that I should probably stress is functions. If I look at f of x being, let's say, I don't know, x squared plus 2x minus 5. I'm just writing this out just for fun. I'm guessing everybody knows what f of 2 is. Yes? Okay, let's be very accurate, I guess. 2 quantity squared plus 2 times 2 minus 5, right? You work out this complicated algebra and you'll end up with 3. What is it? What are functions? You have f of whatever you have here is equal to this expression. Whenever I put something else in the parentheses, means that wherever I saw an x, I have to replace it with whatever I have now. That being said, what is f of x plus h? X plus h quantity squared plus 2 times x plus h minus 5. Everybody sees this? Okay. So if we actually are to work out the algebra, what do we get? Well, what is x plus h quantity squared? And keep in mind, based on the discussion before, it is not x squared plus h squared. X squared plus 2hx plus h squared plus 2x plus 2h minus 5. Right? So if I come back here and I say, what is f of x plus h minus f of x divided by h? Well, it'll be x squared plus 2hx plus h squared plus 2x plus 2h minus 5 minus x squared minus 2x plus 5. All divided by h. Does this make sense?
Yeah.
I will give you a hint. Whenever dealing with difference quotients, well, yes, stuff will cancel out. But when dealing with difference quotients, if your answer doesn't involve h, you mess something up somewhere. The only way you don't get h's is if your function is a constant. If your function is not a constant, you will have some h's somewhere along in your expression. Okay? So, anyway, working it out. Notice that x squared and x squared cancel out, and 2x minus 2x cancel out, and minus 5 plus 5 cancels out. So what we have left is 2hx plus h squared, bless you, plus 2h, all divided by h. Sorry? Factor an h out and simplify with the denominator, right? So h times, what are I left? 2x plus h plus 2, all divided by h. So the final answer is 2x plus h plus 2. Does this make sense?
There's a second test. It said simplify your answer, and I had taken out a 2 out of everything, but it ended up being wrong. It actually kept it without taking out the 2.
Yes, sometimes, and this is why I said I have to go through some of these things, because, for instance, here, so this was more or less one of these problems. If you look at 9, this is more or less what I've done, right? We look at 10. 10 is, again, a quadratic. The only difference is, the only reason why this is actually here versus number 9 is the fact that there is this 2 showing up in front of x squared. Which means when you start writing it out, you have to write 2 times the quantity x plus h squared. And when you square the x plus h squared, you end up with, again, x squared plus 2hx plus x squared plus h squared. Putting a 2 will become 2x squared plus 4xh plus 2h squared, and so it's just a little bit of a variation on things. Is that making sense? Okay? So if I go to 11, it's again a quadratic, the only difference is a negative. So one thing I should say as far as calculus is concerned as a general, and I will probably try and stress out this throughout the semester at some point. Parentheses are your friends. Don't try to do too much, right off the bat. Take it a little slower and make sure you have all the signs correct as you move along through things. So for instance, here I have my function as being negative 2x squared. So my f of x is negative 2x squared plus 4x, I forgot what the other one was, minus 2. Okay? So if I look at f of x plus h now, minus f of x divided by h, it's going to be minus 2 times the quantity x plus h squared plus 4 times x plus h minus 2. And now I have minus f of x. So again, this is why I said parentheses are your friends. If you're not sure, just to be on the safe side and not make mistakes, just write minus the quantity minus 2x squared plus 4x minus 2. That way, when you actually now distribute the minus, you will observe the fact that this changes to a plus, that's a minus, that's a plus. And this way you actually can keep track of things a lot easier than actually just maybe changing this to this minus, but then forgetting to change the other ones. Okay? Anyway, equals ... Unless you want me to do it. But I guess we have better things to do, considering I haven't even gotten to have the test and we have 15 more minutes. So, 12. Notice I got it wrong. This is what I answered, and that's the answer they were looking for. The reason why they said I got it wrong is because I didn't factor it all the way to the end, in the sense that I didn't take out a square root of 11 from the denominator, factor it out, and cancel with, a square root of 11 from the top. So, anyway. On the test, I wouldn't care. See, this is another thing, by the way. This is, by the way, the pretest. This is the way, you basically have to type in your answer and that's it. As far as all the quizzes and the tests and everything else that we're going to do in the class that I'm going to be grading, I always give partial credit. I want you to actually show me all your work. First of all, you're actually going to get penalized if you don't show me the work, because I have no idea where you got it out of thin air. But more importantly, you really should show a lot of work, because if you by any chance have a mistake all the way to the end, you'll still get the bulk of the points, because you at least carried all the way through, and maybe you forgot at the end to add a half or whatever the situation may be, and so maybe you don't get the full points because your answer is not perfectly correct, but at least you get a book the majority of the points because you actually knew what to do and how to do things. Is that making sense? So, as far as the test is concerned, yeah, I mean, I don't necessarily care unless I actually say, like for instance, if I say rationalize this, and by the way, this is another thing that I find a little funny with their particular answer, is because in general, we're always asked to rationalize denominators when you give answers. Well, this is not rationalized. So, it's kind of like one of those things that, it's kind of bizarre. Anyway, is this making sense? Do you want me to do this problem? Okay. So, f of x equals the square root of 11x. So, f of x plus h minus f of x all divided by h is equal to the square root of 11 times the quantity x plus h minus the square root of 11x all divided by h. So the question is, what can I do next? By the way, how many of you got this problem correct, out of curiosity? Okay. That's 0, by the way, in case you didn't look. Why didn't you get this problem correct? Correct is because technically you didn't do anything wrong. I don't know how many of you actually wrote this as an answer. The thing is, you're actually asked, what is the problem saying? Exactly? Find the difference quotient for the following function before to fully simplify. Okay. Well, the problem is, eyeing this looks like it's pretty much simplified. So what's the point of doing anything? Right? Well, this is where calculus comes into play. And what we're going to learn in about a week or so is that the next immediate step that we want to do with these difference quotients is actually take a limit. Now, we don't know what a limit is at this point, but the key idea is we want to make h 0. Okay? And so all of these simplifications basically are enabling us to try and cancel things so we make sense. If you look at this just by simply looking at it right now, what happens if you put in 0 for h? The denominator is 0, which makes no sense, right? And so basically when it says simplify, in reality what they're actually saying is take out the h. That's basically the idea. Okay, we're trying to get to a form in which when I put in 0 for h, I come up with something meaningful. Okay? And how do I know I can do that? Well, because if I put in 0 for h above, I end up with the square root of 11x minus the square root of 11x, which means I end up with a 0. So I end up with a 0 over 0, which, if you think back about rational functions, what does it mean that you get 0 over 0? It means that there is a factor above and below that will actually be able to factor out and simplify. Okay? So as it turns out, if we perform some operations here, the h's will end up canceling out. How do we do that? By rationalizing the numerator. Do you remember what rationalizing means? Yeah, no. Okay. Rationalizing means you're multiplying by something to not have radicals in the numerator anymore. So what would I have to multiply this fraction to not have radicals in the numerator? The square root of 11x plus h plus the square root of 11x. Why plus? Because this will be a difference of squares. Back in the formula that I wrote earlier in the class, this is a minus b times a plus b. That's just a squared minus b squared. If you put in a minus here, and you multiply them out, you're going to have the cross terms of the radicals. That's not what we want, because we want to get rid of the radicals. Is that making sense? Obviously, since this is an expression, I have to multiply and divide by the same quantity. And so now what do I get on the numerator?
H.
11 times x plus h minus 11x. Yes? Remember, a minus b times a plus b is a squared minus b squared. This quantity squared, the square root disappears. This quantity squared, the square root disappears. Right? Yes. Remember, a squared minus b squared, I said as a formula, is a minus b times a plus b. This is a difference of squares. So if I read it from here to here, I'm saying a minus b times a plus b is a squared minus b squared. If you actually FOIL it, right, if you actually multiply them out, you'll notice that the cross terms will cancel out. So you'll still end up with the same thing, right? I mean, basically think about here. You'll have a squared, then the cross terms are going to be a times b minus a times b. That's just 0. Okay? And so we have divided by h times the quantity square root of 11 plus h minus square root of 11x. Right? And what else? Well, now if I look at the numerator, I have 11x plus 11h minus 11x. That's just going to be 11h divided by h times the parentheses. The h crosses out, and we come to the answer that I gave. Right? Which is, you know, very well correct. It doesn't really matter that much. Yes?
Why is that minus instead of plus?
This one?
No, the one on the bottom.
Oh, that's because I wrote it wrongly. I was saving pen energy. Is this making sense?
Yeah, can you show the answer?
So the answer in the yellow box is the answer that I gave, which is basically what we just came up with, right? And so, yes, if you take out a square root of 11 from the bottom, you can simplify it with the top and come back with this. Right? As it turns out, this is why, to me, this was a very acceptable answer, because I'll give you a hint. The reason why we like difference quotients is that the ultimate goal is to come up with derivatives. Okay, this is something that's actually very, very important. This is basically like one of the biggest things in calculus. And as it turns out, if I put in a 0 for h, this is my derivative of my original function. And we'll learn later on that if I am to actually take the derivative, I'll actually end up with 11 over the square root of 11x, which I can simplify more, but that's basically what you first come up with. Okay, let's see. 5 more minutes. Let's look at these things. Is there any point in spending time on these problems? These are exponential problems, and I told you there were some of them in here, right? The graphs, what do we remember about graphs of exponential functions? If this is 5 to the x, forget about the 3 for a second. You're looking at a graph of this nature, right? You start and you go up, right?
Yeah.
The fact that it's plus 3, it's going to shift to the left, but that might not necessarily be that obvious when you select which one of the answers it is. For instance, personally, what I did is I figured, okay, well, what's the y-intercept? I know it has this particular, idea. What's the y-intercept? Well, how to find the y-intercept? When x is 0. When x is 0, you end up with 5 to the third, which is 125, right? So if you look at all these pictures, it crosses at like 1, it crosses at like 5, and this is not of the right shape. Which one is left? Does that make sense?
Yeah.
What is the domain? Everything. Why is it everything the domain? Look at the picture. You start from minus infinity and it just keeps going up. There's really no restriction on it. There's nothing, anything I can put in for x. Yes?
Would just writing x as an element of the reals for the domain?
As far as I'm concerned, yes. As far as the test is concerned, that's the only acceptable answer because they didn't have, if you look at the formulas here, there's no r to say, and it says type your answer in interval notation, so that has to be your only answer. Range. Do you remember what the range is in general? What is the actual definition of the range of a function? All the y values, right? So what would the range be? Well, think about an exponential function. It can never be negative, nor can it be 0. Right? Which means that has to be positive. Does that make any sense?
Yeah.
And then what is the horizontal asymptote? 0. Does that make sense? What is the horizontal asymptote defined to be? The behavior at either plus or minus infinity. What happens when you go far away? And again, think about the graph of the exponential. It starts and it goes up. At minus infinity, it will go close to 0, right? Okay, so let's see. Give the equation of the exponential function. Again, I've seen a bunch of these answers wrong and so forth. Do you understand why that's the case for this particular example?
That's the
Shape. It looks like an exponential function, right? It starts from 0, it goes all the way up. Means it has to be a number to a positive x. Well, that's not the case, right? So that can't be. And then if you look at these, what do you notice? Well, 5 to the x plus 1 can't be this one because the function goes to 0, right? This function can never be less than 1, right? This can never be negative. This is 1, so it can never be less than 1. Well, that's clearly not the case, right? And if you look at the other one, again, 5 to the x plus 1, put in 0 for x, what do you get? 5? Is this function going through 5? So what's left? 5 to the x? Is that making sense? Okay, let's see. 15. Logarithmic functions. Do you remember logarithmic functions? That's good to know. Okay. One of the things we're going to do in this class at some point is talk about inverse functions. So we might do a little bit of a review about inverse functions at that point. Because I've noticed a good majority of you, actually I shouldn't say a good majority of you since I actually didn't look at all 50 tests, but from the tests that I looked at, a good majority of the answers were very off as far as inverse trigonometric functions are concerned. And that's something that we actually need to know quite well, especially when we get to integrals and stuff of that nature. Logarithmic functions are inverses of exponential functions. Okay? And that's basically the idea. The general idea is that y equals ln of x, the simplest function you can think of, looks like this. Okay? Where it passes through 1 here, and it can never be negative, nor can it be 0. Okay? Oh, sorry. The domain is never, x can never be negative, nor can it be 0. Right? And you can see it from the picture. The domain is basically 0 to plus infinity. So if you come back to this problem, well, what do we first know? What do we first notice? It's not doing this. It's actually reversed, right? So two things happened. First of all, instead of being on this side of the graph, it's on this side of the graph. Which means what? There's a minus in front of it. Right? Oh, sorry. There's a minus inside of it. Sorry about that. Right?
minus on the outside.
Minus of the outside means instead of being going up, it flips. That's basically why these problems are set up here. This minus basically tells you that you're reflected over the x-axis. This minus tells you you're reflected over the y-axis. Okay? All right, so I guess we'll stop here. We're at number 15. So we'll continue on Friday because I never actually answered 25. And I don't even know what 25 is, by the way. What is 25?
It's like,
Ah,